Hello and welcome to our video abstract for our paper on perceptions on shape and form. In this video abstract, we'll just briefly cover what shape and form, what we mean by shape and form in engineering design, how we might use machine learning to capture those perceptions on shape and form, the study that we conducted to evaluate its potential, presentation of those results, and then some concluding remarks about how ML could be used to feedback perceptions on shape and form in the design process. So shape and form is widely used in engineering design. We, key thing of distinguishing our products, and we see that all the time in the automotive industry. There is a lot of literature and methods out there for generating and communicating shape and form. So shape grammars and parametric models are just examples of this. But actually, just to confirm whether the designer's desired intention is received by the market in its intended way, well, we still need to go out and get that market feedback. So that's typically through surveys or interviews, using CAD renders or prototypes of the model. And if you've got a global market, you've got to send that across the globe to get that feedback. So sending all that survey information out, retrieving those surveys, processing those surveys to then get something meaningful for the designer to then make some actions and adapt their design. Takes a considerable amount of time, and we want to be able to speed up that process and get more market feedback into it. So we're looking at novel ways of capturing that perception of shape and form, so we can have it fed back into the design process more readily. So what do we mean by really shape and form and these kind of transitions? Well, let's take a square or circle. So I'll give you a moment to have a look at the transition, the transform of the square and circle, and where you feel the transition point is. So for myself, I'll look at 9 as probably my point of transition. It might be 8 or around there, but the mathematical representation here of the transform would probably indicate it as 5. So what really I'm just trying to illustrate here is that, if you use a mathematical equation here and define the midpoint as a transition, it is not representative of, a user's perception. So that's what we're trying to capture through novel methods. And we're using machine learning to do just so. It's great for classification tasks, just like we have there, a square or circle. And we're using convolutional neural networks to achieve this. So this whole paper is about, can we actually use that machine learning to capture the different perceptions of shape and form? So the study was a 4-step process of creating a shape data set of 2D primitives and the transforms between them, generating a survey to capture the user perception of what they believe the classification and where the transition points of those shapes were. We then analyze that survey using Fleece's kappa to see if there was consensus across the population. Do we all perceive these shapes and the transition points in the same way? We then subsequently looked at training and validating CNNs to see if it could replicate the population's perceptions of these shapes and form. So the results showed actually, the Fleece kappa showed that population overall had had a strong correlation that we all do perceive shape and form in very similar ways, which is what is probably to be expected. There are some interesting features though if you dive deeper into the data. So like you say here, we've got triangle to circle. There is a clear transition point between when people consider it a circle over a triangle, but triangle to square, that perception is a lot more broader. So the transition point is a lot more broader. So it shows that some shapes are more defined in a human's mind than others. We looking at the CNNs, what we identified is that actually it is representative. The CNNs can be representative of a population with achieving scores similar to that of the Fleece's kappa to say that it is representative of user in a population. What we also identified was that the CNN architectures were very similar, so the structure was the processing of the data was very similar, but it indicates maybe how you weight the ML is critical on the type of code, how you codified up that data, be it through the mathematical equation or through human perceptions. So in conclusion, machine learning has the potential to capture perceptions in shape and form. This would then be able to provide that real-time feedback because we could feed in, renders of potential products, and then use that as the user feedback straight in the loop. Our next steps are to scale up the studies, look at more rules and identify maybe implicit rule sets. What makes a chess piece a king, queen, or pawn? Can we classify and identify those through ML? And what are the distinguishing features of our products? So thank you very much for listening, and if you want to read more on the subject, here are some of our papers, and I'd really like to hear your feedback and questions. Thank you very much.